Let's take a look at a trig example of the definite integral and using the fundamental theorem of calculus to evaluate that definite integral. Here we have the definite integral from 0 to pi of sine of x dx. As with our previous problems, we are going to begin with the antiderivative of sine, and that is negative cosine. We're going to evaluate that from 0 to pi. So we get negative cosine of pi minus negative cosine of 0. Now, cosine of pi is negative 1, so we have the opposite of negative 1 there, minus cosine of 0 is positive 1, so we're going to get negative 1 out of those parentheses. That's going to give me 1 plus 1, or 2. So, strangely enough, here we're dealing with a trig function, and we know that in general for function values, the trig functions take on things with square roots and 2's in their denominators and all sorts of interesting values. And yet when we look at this specific definite integral over the interval 0 to pi, we get a nice integer value, just 2. The more and more you look at the trig functions, the more and more you'll find things that about them, I should say, that surprise you.